Hey, Alessandro, I'm going to work through what I think is the problem that you were talking about. And after you look at it, if you want to get together and talk about it, we can do that through Zoom or WebEx or Google Meet, whatever works for you. Okay, so let me bring this up and I'm going to work through it, talk through it, see if it helps you. And of course, the first thing I want to know is make sure this is the problem that you're talking about. I think it is. Okay, so here's the problem I think you're talking about, and there was another problem that followed down below it. But so I haven't actually worked this problem in a while, so it'll be good to go through it, and I'll try to point out some things as we're looking at it. First thing I'll show you here is that in the circuit as it's drawn, it's showing the current direction given. Now, let me pause just for a second. And when you do that, and even if a circuit doesn't actually have that designation on it, you can just do that yourself. And if you choose the opposite direction, ultimately it will all work out. I mean, you're adding things algebraically. This is why you basically learn positive and negative numbers, to allow you to do stuff like that. So as I look at this problem, if the current, and we're talking about conventional current, that's our normal way uh, of working in this course, then if current is in this direction, then across a particular resistor, the polarity would be this. It goes from positive to negative. Now, and you follow that through all the way around because current in a series circuit is going to go that way. Now, I think what makes this sort of confusing are these two voltage sources. A good way to think about that, and at some point you'll do enough of this to where this is all just second nature to you. But the longer line, of course, is the positive terminal. So here's that 10-volt source, and if I were to redraw that and just pull out the sources in this circuit, then this is so this would be the 10-volt, and this would be the 15-volt. And so in a series circuit, you can look at the two voltage sources, this way as you go through. So as I'm looking at that, what I basically have, if I combine those two things, as you go around from this, you would say minus to plus, you're at plus 10 volts, and then plus to minus, you're at minus 15 volts. So your net voltage is minus 5 volts. And that's probably the key to working this problem is to be able to get that portion of that. So what you would do, what you would sort of do with that, understanding, this portion of this and being able to figure out what way you're comfortable in making that determination. But when you look at this source in series with this source, the net voltage, if you're going in the direction shown, if you're going in this direction shown, is as we're saying. So the hard part of this is being able to recognize that you should be able to redraw this circuit, and good circuit analysis is all about taking the different forms of this and redrawing them. So what I basically have, if I'm going to maintain this direction, is I have a 5-volt source that's going to be oriented this way. Okay, that is the key to solving this problem. And so I can combine the two voltage sources because they're in series. This becomes V3, and this becomes V1, and this becomes V2. Now, I have a totally different circuit now, don't I? Because, originally I designated because of this source that the current was going in this direction. But now we know actually, redrawn and rethinking about this, that we have a 5-volt source And the current would actually be going in this direction, right? And the polarity, if current is going in this direction, is plus to minus, plus to minus, plus to minus. And you know you're doing the right thing here because see the minus connected to the minus. So that's what you would have across there. The values, you know, for the resistors are still 5K, 1K, and 4K. All right. Now, so the total the total resistance for this is 10K, and the total voltage of the two combined sources is 5 volts. So 5 volts divided by 10K is going to equal, what is that? Let me just put it in the calculator right quick so I don't go down the wrong path here. So 10,000 divided by, excuse me, 5 divided by 10 to the third is going to give me 0.5 milliamps or 500 microamps. You know, you might see that written a couple of different ways. I think he's writing it in terms of microamps. So we know it's 500 microamps, which would be the same as 0.5 milliamps. Now, the question here is, do I say that that's a negative current or do I say that's a positive current? All right. Well, first off, I know the answer is either here or here. And so how do you know if it's positive or negative? Well, the best thing I can tell you there is just by the rules and the formatting of these types of things. You have to go back to your original equation. And based on the original equation where he's saying I is in this direction, we know it's really not that direction. So if I had to pick one of these, then I'm going to say that my answer is minus 500 microamps. Now, there's a lot in that, you know, a lot of different parts, moving parts to that. But look that over, see if that makes sense, and then get back to me, and we can work more of these. And what I might do is go down and look at the second problem below this and work that for you too. Okay? Hope that makes sense. Let me know.